of 9. Yes, it is. But you have to add your starting point.
Why do you have to add your starting point?
Because this if you're, I want to explain this. Your six is relative to 0.
Okay.
But you're not starting at 0. Like if the question were, let me try and let's say the question was from 0 to 9. 9 minus 0 is 9, but and 2/3 of that is 6, but you're starting at 0 rather than at 1.
Okay, so since we're starting at 1, we have to add the starting point.
Yes, or whatever the starting point is.
So if it was like 2 to 10, then it'd be 8 plus 2, right?
Well, yeah, or whatever the number is. Like, let's say it was like if I want to know 1/4, this is from 2 to 10. Actually, let's make it 3/4 from 2 to 10. So 10 minus 2 is 8. 3/4 of 8 is 6, but you have to start at 2. Because if you look at where 6 is between 2 and 10, not to scale, 6 is right in the middle.
Mm.
It's not 3/4 of the way. You have to push it over to 8 where it actually is.
Okay.
So they like what they're referring to here is like sort of relative position. You have to know where it's relative to where you start.
Okay.
Okay. So like this applies to something. Do you ever go hiking?
Uh, Not often, but a little bit, yes.
Okay. But you've been hiking before, right?
Yes.
Okay. So like Tucson is, I don't know, I'll just say 3,000 feet above sea level. I don't know if that's right or not, but it's not that far off. And if you hike something where you go up 1,000 feet, you're now at 4,000 feet, right?
Right.
Okay. Now, if I go to Colorado and I start at 5,000 feet, these aren't to scale. Let me make these a little more to scale. And I climb up 2,000 feet, and now I'm at 7,000. Okay. That doesn't mean that doesn't mean that I've only climbed twice as high as I normally do when I'm in Tucson. Because it's relative to where you start.
Right. Okay.
I'm trying to think of some other examples here where that really matters. It's that launching point. It's like, once you're, yeah, I'm trying to just think here. I don't have another good example of this, but hopefully the idea is clear.
Yes.
So maybe. Okay. All right. Okay, let's look at 17. Oh, actually, let me give you a real. So there's we think of underwater fishing as being at sort of at like sea level.
Right.
But if there's mountains where there's lakes up there, and they're 10,000 feet above sea level. There's one
Right.
in like Peru, I think.
Are
And
they still considered sea level though?
no, but and what's interesting that I was watching a documentary on this is like the pressure is different. Obviously, if you're at sea level and you dive down 1,000 feet, or I don't even, that's probably unreasonable, but let's say 500 feet. It's really different than if you dive down 500 feet from 10,000 feet starting. The
Right.
pressure, the oxygen, all that stuff that, so your lungs don't explode. All that stuff is really important. And they don't know very much about this because there's not that many opportunities to dive at, such high sea level or such high level elevations relative to sea level.
Okay.
I don't know. Let's get back to math. All right. So distance formula again here. You really got to know your x1, x2, y1, y2. Okay.
Right.
So your distance is the square root of, and let's just say you're like, oh, it's -2. I'm going to do y2 first. So -2 minus 4 plus, now x2, 3 minus Always put those negatives in parentheses like that, especially when they come after an operator.
Right.
So this time, just to be clear here, this time I did y2 minus y1 squared and plus x2 minus x1 squared. The order doesn't matter.
Right.
All right. So -2 minus 4 is -6. Squared is 36. 3 minus a -1 is 4. 4 squared is 16. Okay, so now you combine these, it's the square root of 52. Do you remember in class what you do from this point since it's not a perfect square?
Um,
So
no.
you have to reduce the root. And to do that, there's two approaches. There's either a factor tree or a factor ladder. They're basically the same, but some students know one more than another. Any
Mhm.
idea what I mean by either of those? Factor tree, factor ladder?
Um, I've heard of factor tree. So factor tree is like you take the number itself and then divide it into what it could multiply out as.
Yes, and you start with prime numbers, and the smallest prime number is 2.
Right.
The 2 times 26, and then you keep going, 2 and 13, and you stop when you get prime numbers on the leaves here. Okay.
Right.
Now for every pair, it has to be a pair, you can take one out. And anything left over stays in. And if you're not sure what I'm referring to, with a square root, oh, that's bad. With square root, there's an out and there's an in. Okay, so you're gonna bring a 2 out and the 13 stays in.
Right. Right. Okay. Because the prime number sticks out and then
The pair, if yeah, whatever the pair is, like, and there could be more than one pair, there could be different types of pairs, all of that. Okay. So let me just give you a root to reduce just to see how familiar this is. Could you reduce the square root of 24 for me?
square root of 24.
Yes.
3,
You got to,
2.
you start with 2. You always start with 2.
Oh, right. 2 and 12,
Okay.
3 and 4,
You keep trying 2 until it doesn't work.
2 and 6,
Keep going.
3 and 3, 3 and
2 and
2.
3, 2 and 3. So
So,
you keep going until you can't use the number anymore. Okay.
right.
And then you might switch to another number here. So this is a pair. So 2 comes out. There's no pair here, so these go in.
And so they multiply together or
They
they
do.
add together?
They multiply. It's 2 square root 2 times 3, or really it's 2 square root
6.
6.
Okay.
Okay, so let me have you try another one here if that's okay, because I'm feeling like this is not familiar to you and want to make sure you understand how to do this. Would you try this one on your own, please?
Um, 2 and
Go ahead and work this out completely on your own if you don't mind.
okay.
This is the try it out part of the lesson.
I lost my pencil. What the heck? Oh,
Yeah, I mean, if you need to go grab a pencil, paper, please do. I mean, since we're not in a rush to get stuff done, it'd be great for you to work a few of these out on your own.
oh yeah, I got a pencil now.
Great. So go ahead and try working this out. If you have questions, please ask, but just give it a try. See what you come up with.
So on the outside, I got 2 and 3, so 2 times 3, and then on the inside I got 2, so 6 root 3.
Two. You
Root
said
2,
two.
yeah.
You said two on the inside. Yeah.
Yeah, 2 in the inside.
Yeah. That's perfect. That's perfect. Okay. We don't have to spend any more time on that. Just wanted to make sure, we covered one. All right. So I think we're up to 30. We're up to 7. Yeah, we did 1738. All right. We should do one midpoint formula before we do 38.
Right, okay.
And I'll choose one that's, I don't know, choose one of the fraction ones, I guess. So another formula here. The midpoint though is not, I mean, here's the formula. The formula is x1 plus x2 over 2, y1 plus y2 over 2. But here's the formula in words. Average of the x's, average of the y's. Okay, and you probably remember to take an average, you add them up and divide by the number of numbers. That's it. Okay, so like you can remember this formula, or sometimes the words are more meaningful. Okay, so for x here, it's 1/2 plus minus 1/3 divided by 2, comma 1/3 plus 3/2 divided by 2. Okay, so let's focus on the left one here. How do you add two fractions with unlike denominators?
Multiply them by the respective thing. So like 1/2, you would multiply by 3/3, and then
Good. So 3/6 plus, and then the other one on the right, minus 2/6
right.
over 2. So the top becomes 1/6 over 2. Oops. Over 2. Okay. Now, do you remember how to deal with this number on the bottom, where it goes?
It multiplies into the fraction.
It does. Like, you can visualize it as follows. You can visualize it as multiplying the top and bottom by 1/2. But if you do
Right.
this enough, you realize that 2 just goes to the bottom. So it becomes 1 over 2 times 6, or 1/12.
Okay.
Okay. So on the right, same thing here. We got 2/6 plus 9/6 over 2, which is 11/6 over 2, which becomes what? What is that reduced to?
11/12.
Good. Okay, so there's your midpoint. Again, probably more easy to remember. It's the average of the x's, average of the y's. All right, now let's do 38, because we now know enough to be able to do it.
Okay.
Let's just getting this snipped in. All right, here we go. All right. One end of a line segment is -6, 4, and the midpoint of the segment is -2, 7. Find the other endpoint. There are two approaches to solving this problem. One is to use formulas, which is the one we were just given. The other is to use what I call like the jump method. I'd like to show you the jump method before we go to
All right.
formulas.
Please, I'm very curious.
Okay, so we got to know where we're starting from. Which one are you starting from? Basically, which is the endpoint?
-6, 4.
Okay, and what's the midpoint?
-2, 7.
Okay, so my question to you is what is the jump from -6 to -2? And the answer is you're either adding or subtracting a certain amount. How do you go from -6 to -2?
You add +4.
Good. So the endpoint, you will also add +4. So what is -2 plus 4?
+2.
Good.
Why did that take so long?
Well, sometimes the brain isn't, fully functioning. You just got out of school, there's lots of reasons. So what is the jump from 4 to 7?
Adding 3.
Good. So you must then again add
3.
3. So what is the other endpoint?
10.
10. So this works really well for whole numbers if you can see it. Doesn't work as well for fractions, but the way to do it is to go like the positive 4 is really -2 minus a -6, and the 3 is really 7 minus 4. So it's right minus left.
Right.
Okay. Do you like the jump method?
I do. Yeah.
Okay. You do have to make sure you know where you're starting from. You can't like start from the midpoint and go to the endpoint. That doesn't work.
Right.
You have to use the endpoint first, then the midpoint to get the other one.
Right. The jump method seems familiar.
It's a shortcut to the midpoint formula. I mean, it's more of a visual approach, whereas the midpoint's more of a just formula based.
I see.
Okay. Number 45. Verify that the points 4 comma -5, 6 comma 7, and -8 comma -3 lie on a circle that has its center at -1, -2. So we're going to draw a circle, and we're going to pretend that that is the point -1 comma -2. And I'm going to draw something. Can you tell me what that is that I've just drawn?
Radius.
This radius. What about this?
The radius.
Agreed? How about this one?
That's a hard one. I'm gonna have to say the radius.
Very good. Now all of the radii are congruent, meaning
Okay.
they have the same distance. So this problem is a really complicated way of saying to find the distance from this point to the center, the next point to the center, and
Mhm.
then the third point to the center. And they should all equal the same thing. Okay, so let's do these one at a time here. Okay, so let's start with the let's start with 4 -5 -1 -2. So we're going to go let's see here. Let's go x1 y1 x2 y2. So
Okay.
it's 2, so y2 minus a -5 squared plus -1 -4 squared square rooted.
And that would be 7 squared to 49 plus -5 squared, which is 25.
Good. So this ends up being the square root of 84. No, 74. Okay. You do not have to reduce this. And if you're wondering why, it's because if 3 lengths are equal, the square of them is also equal, or the square root of them is always equal.
Okay.
So it's and that's useful in calculus and other science engineering classes. You just need to show that they're equivalent, not their reduced form. So I want you to find the distance. And so what I would do is for the next one is I would just shift this over, make that x1 and y1, and then do it again for this and make sure they're all square root 74.
Okay. Okay. So root y is first. So 2 -7 squared plus -1 minus 6 squared. That would be -5 squared. Yes. Same thing, 25 plus 49, which is square root of 74.
Good. So when a problem says to verify, you already know the answer. You already know that it's supposed to work. So you're just showing enough to indicate that it does work, which is what you're working through.
I see. Okay, so then they're all going to be root 74.
Probably, but you should verify that. You should do the last one. You should just work that out, make sure it does actually give you what you think it's supposed to.
Okay. Square root of 2 minus 3 squared plus -1 minus 8 squared. That would be 5 squared plus 7 squared. 25 plus 49. 74. Square root.
Right. Good. So it does work. That is a verify. They're only sort of frustrating if you can't verify it or you're getting something different than what you're supposed to.
Right.
Okay. Well, so let's just summarize here, because this part of the lesson is it's there's a few things here. The distance formula is the square root of y2 minus y1 squared plus x2 minus x1 squared. And believe it or not, this is very similar to the Pythagorean theorem.
Kind of, yeah.
Yeah, it's actually exactly the same, but it's better to remember it this way. The midpoint formula is x2 plus x1 over 2, y2 plus, I'm indexing this wrong, but the order doesn't matter. You can do x1, x2, but it's an average.
Right.
And then where I thought you were going was the standard form of a circle. But that's to be determined. I don't know if that's where you're actually going here. So we've got, lots of time here. Would you do you have something else you can send over for us to look at, or I can give you more problems like these?
No. Can I instead of the general form of a circle, I meant like ax plus by equals c, because
That's
I'm
right.
getting,
That's right. You said standard form.
yeah,
Okay.
because I'm getting really confused on that during class.
Okay. Like, what kinds of questions are you being asked? Slope, graphing, intercepts? What are they asking you for?
We have to find, so one of the questions we got asked in class was write an equation of a line perpendicular to something in general form that
Okay.
passes through a point, and then he
Yes.
said we had to change it to point slope, slope intercept, and then back to general.
All right. Got it. Okay. Yeah, that's quite a bit there. All right. Yeah, so let's look at let me make a problem here. Let's go 4x minus 2y equals 6. Okay. Could you determine, well, let me actually this, so this is in standard form, and Is it clear why this is in standard form?
Uh, yes.
Okay, there are three
In or isn't?
it is in standard form because there's like three things that needs to be in standard form. The first is that X and Y are same side,
Right.
no fractions or decimals. Basically it's got to be integer. No fractions or decimals. Let me get that word in there. And then, so really that means whole numbers or integers. Okay, but the last one is that the A has to be greater than 0. Basically, the coefficient of A is positive. Okay, so like if if it was -4, it would not be in standard form.
Why not?
Just that's the rules. A has to be the leading coefficient has to be positive.
Okay.
I don't know why. I don't know. I mean, that's just whoever came up with it said these are the rules. Okay, so if we were to build a flow chart and an equation was in standard form here, if we wanted to go to slope intercept form over here, here's how you do that. You solve for y.
Right.
So we're going to go back to this equation and I want you to solve for y, or if that's unclear, we can work through an example together, but I'm pretty sure you can do this. So I just want you to solve for y, please.
That would be oop, 4x minus 2y equals 6. X, 4x, negative 2y equals. Y equals 2x minus 3.
Like this.
Yes.
Okay, yeah, let me just double check here. So it's minus 4x plus 6, y equals divided by -2, so 2x minus 3. Perfect. Okay, what is the slope and what is the b value of this?
The slope is 2 and the b value is negative 3.
Good. Okay, now regarding well, let's start with parallel lines. Parallel lines have the same
Slope.
slope. Perpendicular, not so much.
Yeah.
Perpendicular lines have, well, there's a few words that can go in here. A couple, the ones that I usually see or say are opposite reciprocal, opposite sign reciprocal.
Yeah.
Another version is flip negate.
Interesting.
Okay, so let's look at some slopes now. So here's the original slope, and then slope perpendicular. That symbol there means perpendicular. A little, I don't know, hammer, maybe line. So let's say the slope is 2/3. Can you tell me the perpendicular slope?
Uh, negative 3/2.
-3/2. What if the slope is -1/4? What is the slope? Perpendicular slope
4.
is 4/1 if you want. What if the slope over here is 2? What is the perpendicular slope?
Negative 1/2.
-1/2. Okay. Now, I want you to multiply this number times this number, this number times this number, this number times this number, and tell me what the result is.
Multiply the m's. Okay.
Yes.
So, oh, they're all -1.
They're all -1. Isn't that interesting? Yeah. So that's a check. They don't teach it that way, but that is why it is opposite reciprocal or flip negate because of this.
Okay, that makes sense.
Yeah. Okay. So to go back to our original problem, they give you this right here, 4x minus 2y equals 6. But the real question is they want you to determine the equation of the line perpendicular through, and I'll make up a point here, minus 5, 7. Okay. So here's what you've done so far. You put this into slope intercept or point slope form. Sorry, slope intercept form. 2x minus 3. You found the slope was 2. What is the perpendicular slope?
Negative 1/2.
Negative 1/2. Okay. Now, very important. You throw the rest of this stuff away. You don't care about any of this anymore. You've
Right.
extracted everything that you needed from it. Okay. You ever yeah, it's like you get all the juice out of the orange, grapefruit. There's nothing left. Just throw it away. You're done with it. Okay.
Right.
Now, if it doesn't specify, there are 3 forms of a line. Okay. Y equals mx plus b, which you need a slope and an intercept for. Point slope form, you need a point and a slope. Notice the name tells you what you need. The first one is slope intercept form, tells you what you need. You need a slope and intercept. Second one is point slope form. You need a point and a slope.
Yeah.
What do you have now? What is this considered?
A point.
And this is
A slope.
slope. So you should use the one that is the easiest path of least resistance here, right?
Right.
So you're going to use this one right here, and you're going to substitute in your point. So you have your slope of minus 1/2, and your point is, what did I say here? Negative 5, 7. Okay. So this is your x1 and your y1.
Right. And they always have to be x1 and y1. They can never be x or y.
That's correct. That's correct. Yeah. So y minus 7 equals minus 1/2 x minus a minus 5.
Okay.
And you're done.
And that's it.
That's it. I mean, you should write x plus 5, I suppose, but that's a small thing. Now, there's that third form of a line. Sorry, my screen just froze up. I gotta do something about this.
It's
AX
fine.
plus BY
Schools have
equals.
been.
What's that?
It's fine. School's been having. Apparently, we got hacked, so all of the resources that the teachers use are all down.
How does this happen? I can only imagine they're like, hey, we can't teach you today. We don't have resources.
We can't teach today. However, you still have homework, so we're gonna do this instead.
Uh, yeah.
It's
All
it's
right.
hilarious.
All right. So with standard form, you never directly go to standard form. Okay, so like you always have to come from somewhere. So if you saw earlier, remember I made that I had that kind of that flow chart here. So here's standard form, ax plus by equals c. The most common path here is to go from point slope to y equals mx plus b to this one. Okay. And then in terms of like, well, how do you go backwards? You typically go from standard to slope intercept, and then slope intercept back to point slope, although this is generally the hardest path to make for most students. So you generally don't do that, but here's what you never do. You never go from standard back to this. You always, make it's like getting to Flagstaff. You're in Tucson, you're going through Phoenix up to, Flagstaff. You rarely, you don't go, there's not really a way to go there without going through Phoenix. That's reasonable, we'll say.
Right.
Okay. So having said all that, I should ask you to do a problem here. And it would be something like this. It would say, write the equation of the line perpendicular to 5x minus 2y equals 10 through -1 minus 2. Yeah, that's enough. Okay. So it's just like the last problem, it's just a little bit more formal. You have to extract the slope of this line.
Okay.
And to do that, you cannot do it in this form. You have to take it and put it into slope intercept form. You need to solve for y. So you need to, I want you to solve this equation for y.
Okay. So y is, oh, I can't write. 5 halves x plus 5. No, minus 5.
So I like there's steps here. Minus 5x plus 10, divide everything by minus 2. So y equals 5 halves x minus 5. Okay, so what is the slope?
5 halves.
Okay, but we don't even want that. We want the perpendicular. What is the perpendicular slope?
-2/5.
Good. Now, what did I tell you that you can do away with now? What is,
The reversal.
I mean, this is what you need. Everything else doesn't matter.
Right. Okay.
All right.
So
Now, did I specify the equation? Did I say thou shall use anything, or did I just say write the equation?
you just said write the equation.
Which means you get to choose. Okay. Now, you generally start with either point slope or slope intercept, and it
Right.
depends on what you're given. Do you have a slope and intercept, or you have a point and a slope? So look at what you have here. Do you have a slope and an intercept, or do you have a point and a slope?
Point and a slope.
All right. So that's telling you, it's telling you, you probably ought to use this one. Sorry.
Right.
And again, the name of the equation tells you what you need, what's missing. Right. So you want to try that for me? Do you want to, can you give me that equation, please?
Yeah. So it would be, you substitute the y1 and x1 with -2 and -1 respectively, and then
Okay.
it would be
Give me your,
y
yep. Give me your final answer whenever you're ready.
y plus 2 equals -2/5 times x plus 1.
Good. Okay. Now this is in point slope form. Yay. Okay. Now, what if I said, oh, I really want it in slope intercept form? Okay.
Multiply the -2/5 into the x plus 1 equation, right?
Okay. Done that. Is this in slope intercept form?
Not yet.
Okay. What else is there to do?
Subtract the 2 from both sides. And then it should be y equals -2/5 x minus 2 and 2/5.
So you don't use mixed numbers hardly at all. You'd want to say, oh, this is really -10/5. Because you want to match the denominator here. Yeah.
Oh, right. Okay. And
Yeah,
then, so it'd be 12/5.
exactly. Okay, now this is in slope intercept form. Yay. Right now, what if we wanted it in standard form? So standard form, I mentioned to you at the very beginning of when we did this, I said, first thing is x and y have to be on the same side. So that's easy enough. You add the 2/5 x over. So it would be 2/5 x plus y equals -12/5. Do you remember the second requirement?
A cannot be negative.
That's the third. So no fractions. No fractions.
Oh, shoot.
So you have to eliminate the fraction. Now, more specifically, it needs to be in lowest terms. Okay. So
Right.
like you could multiply this by 100 and it's no fractions, but the caveat there is gotta be the lowest. So you'd multiply everything by 5.
Right.
So it'd be 2x plus 5y equals minus 12. And like you said, a has to be positive. Now it's in standard form. But notice the progression. Notice progression, okay? Point slope, slope intercept, then standard form. It's this diagram here.
Right.
All right. So we're going to stop recording there.